So as I was testing the big balls in my backyard and the wheel hex cracked in half. So now I have to model a new one and 3D print it. So I'm just gonna kind of show the process, and this is what it looks like. There's a chunk missing, and pretty much just this circular hex and place into those 4 holes to hold it in place, and there's a shaft that go in between them. And I'm just gonna take some measurements of this wheel hex, and I'm still learning. I'm just starting to do some 3D printing and modeling, so I'm not the professional. But here's just a quick way how I do things. So I'm just going to take out the outer diameter around 28.4. Doesn't have to be that exact because there's some space in between each side. So I'm just going to take that, and from what I remember, there's a plus or minus 0.2 millimeter difference for my printer. So I'm just going to put 0.8.4 in the computer so I can keep track of it. And then for the width of the pin, I'm just going to do the width here and see what the difference. So 12.2 versus the actual pin size is 12. So I can probably print the shaft to be 12.2, because if I do it 12 exactly like this, the width of this pin, then the hole might not fit it perfectly because you need some space for it to move around. And for a prototype, I don't want to make it too tight, and you can always adjust it later. So 5.6 for the shaft diameter, and we measure that compared to the actual shaft. So 5 is the actual shaft width, and 4.8, I would do 5. Let's do 5, because since this is plastic and there is like some gap in between, and I wouldn't trust that as much, but it's just good to have a couple different reference or points of reference. 4.8, and now I'll just do 5 for shaft. Put in my computer on the shaft, and then outer diameter. And then now I gotta do the thickness. So thickness, I'll use this part of the caliper at the bottom end just to check the depth. The depth is around 2.2, 2.4, and 2.4 is the depth. And then I'll check the actual thickness of this. It's actually 5. So if I do this here instead of, yeah, it's around 5. So let's do 5 for thickness. 5 for thickness of the wheel hex. In each individual wheel hex, I mean the legs, I don't know what to call them, but the attachment point to the wheel, let's measure that as well. This is the height of those 4 attaching points. So it's at, I would say at 3.2. So that's, and then the width, the diameter, the radius, not the radius. The diameter is 4.7. So 4.7. So all these numbers are just estimate, and I think that's pretty much what I needed for this piece here. And I think I just need one more. One more thing is, how deep is this the shaft? So I can, because it doesn't go all the way through for the center shaft. So now let me take the thickness of this. It's 2.3. So it's 2.3, 2.4 millimeter deep for this shaft. 2.4 deep. So after all those are done, I used to use Fusion 360 when I was a student, and they have 1 year free trial or subscription, 1 year free subscription. So I used it for a little bit, but I wasn't studying like 3D design or anything. It was just using that student benefit, like what I said about other benefits before. You gotta ask, and then you get it, and if you don't, then it's your own loss. And next is, now I'm going back up here to my monitor, to my screen. I don't know if you can see it. Let me turn on my lights now. So now I made some measurements of the wheel, and now I'm gonna go to Tinkercad. This is the free version, so most basic. I'm just gonna do this, do a circle, 28.4 diameter on both, 28.4, and then for the sides, it looks all rough, not like a smooth circle, and then we just do the sides and make it smooth as much as possible. Now it's like a smooth surface, and the thickness of this is 5. So now you have this piece. It's pretty simple. And on top of that, you have to make 4 of those little legs, and I would just do 4 of those, same thing. And those legs are 4.7 by 4.7, and then the height is 3.2, and there you go, 3.2 height. And I think one thing I forgot to measure is, let me bring this back up, because now you have 4, you need 4 of those, but where do you place them? So now I need to measure the distance for those legs. Like they are not perfectly on the corner of those. So I gotta take that piece, take the original piece if I want to, and then measure how far off they are from each corner, because they're right at the corner, so you don't have to measure the space, but you can measure this distance. Distance, center, I guess space is sufficient enough. Center to center, it's around 17. So I would say 17, center, hole of the center. Okay, so you can do that. But first, let's make sure I got this right. 4.7, yeah. So sometimes in the chart or in the software, they look pretty big, but they're not. So you need to make 4 of those. 4 of those. Control D, and 4 of those. I'm not very good at this, but you make 4 of those. And I think there's a better way to do it. If I put it at like 17, and then they can do it. And you raise it. What is the thickness of this? 5, and then you raise it by 5. By 5. Nope, 5. So now you can move this over here at one corner. And then you have to use a ruler to measure the distance to make it 17. Let's do 5 on this one too. 5, no, 4, 5. So we just gotta make sure they're one end to one end. They're 17. They're not 17. See? Let's put 17. And then I think if you drag it on top, that's pretty much where you need to put it. Just align it to the edge. We're at 1 millimeter per move. So I'm sure there's a better way to do this, but I think now if I duplicate this, copy D, well, let me do this 2 objects together. Control D, and then just line them over here. See, there you go. Now you have 2 of the same thing. And can delete those two. And then now, looking pretty good. So now we have to cut a hole in the center, which is the shaft. Is 5. Let's just do this here, make sure it's 5mm, or 4.8, so we make it 5 so it will have some space to move. 5 and 5. Lengthwise, doesn't really matter. Let's combine those shapes first, combine them, done. And then now I want to center these two pieces, so now it's center on those pull points. Now the shaft is right in the middle, make sure it's completely smooth too. And now you combine them again. So now you have a hole in the center for the axle. Now we can turn this over to 180. Now it's upside down. So now what we need to do is the center shaft, I mean the cross shaft that goes into. So the cross shaft is wait, let me do this 180 again. I don't know if I made the heights of those legs correctly. Let's do it at 180. So the heights of the legs, separate them completely. This one, what's the height of this? Oh, that's correct. Never mind. So I thought the heights for those legs were not right, but we got it. So now I just kind of went back and reversed it. Now it's back to the bottom end. So now let's focus on this piece. Make sure it is completely rounded out right here. And then the thickness of the shaft is 5. So we just do 5 out of 5. 5, that's the thickness. And then the width is 12.2. 12.2 width. Let's measure the actual piece first to make sure it's 2. Thickness is 2. This is 2. Let's do 2.2. Width is 12. I can do 12. Let's do 12. 12. 12.1. Give you some space. Thickness is actual thickness. This is 2, so we make it 2.2. 2.2. 2.2. Actual thickness. Width is 12.1, and that's pretty much it. And then we rotate it at 90 degrees. And what's the height of this? The height is at 8 from this is 8.2, ground 2. So I just have to make sure. So this is at ground level. 8.2 is the actual height of the surface, and I need it to be 2.4mm deep. So what I need to do is 8.4 minus 2.4, which is 6. No, 8.2, never mind, 8.2, not 8.4. 2.4, 5.8. So it has to be at 5.8 height. So I'm going to raise it by 5.8. And I can actually do it a little deeper just to be safe. Because if it's too shallow, then I don't know if it's gonna, it might come out. So 8.2, 5.8, that's to 5.7, and it'll be a little deeper. And then now I'm just gonna align it. Align it with the center. So center, those 2 points. It feels like it's not showing up on the surface. Oh, I just remember, since this is, the shaft is it rounded? It's actually, the top half is not, only the bottom half is rounded, so we can just do pretty much half of this. since, and we can do it a little thicker, like 3, then I can bring this down a little bit lower. So to do the proper math, you have to make it level. And if I do 3 and going down, so if I bury this and then go up, it'll be negative 1.4. Right now it's 0, completely submerged. So if I do half, it's 1.4. And the actual depth we need 2.4. So I need to increase this by another millimeter. So additional, so we do 4. The height, and then we can drop this to 2.4. Okay, now this is the shaft, looking pretty decent. So now we're gonna combine this again. Boom. Combine them, not separate them. See, now we have this piece. This is pretty much what the shaft looks like, and then the cross shaft, they're all center. And bring this back 2.4 millimeter deep, and then rotate this 180 again. When I print this, I probably need some support for the hole. And then I'll just print it like this. And does this look like? So let's measure this. So this is the edge of this. The center. This, and I'm just trying to get a couple more points to get a better reference of the placement of this, since I'm not very good at this. So 22 is the outer, and then the center is 17. And somehow this circle doesn't look too rounded, but I'll see. Okay, so I'm just doing some little adjustment because when I moved it around, the size actually changed. That's why the circle wasn't really completely round. So I'm changing the units back to the actual units, and then I'm using a ruler to measure the distance of each piece. Focus. And then now they're all both 4.7, and then the distance have to be around 17. I mean, technically I can delete this too because I'm just going to duplicate this. Duplicate these two, and then bring them over. Because for that side, the width is good. So I'm just going to bring this back in a little bit. We have a millimeter. And then that's pretty much it for this piece here. They look pretty good. And I'm just going to combine all of them. And there you go. This is the real hex. And I'll print this out and see how it goes. So 15 minutes later, got the finished product. And I printed a couple of these in case the other side breaks too. So this is what the original looked like. And this is the printed out version. So this is the front side, the back side with the shaft. And maybe this one, yes. So this the shaft is snug. And then what I need to do is put this in here, and it goes in, and there you go. That's pretty much how it works. And then for this end, just drop it in, and that works pretty well. It fits. And now you just do it like that. And now you can screw it in. There you go. Boom. I'm gonna test this out, mount it back on the car, and probably record another video of this.